No one else is people. There were 3 of them downstairs in the suite. First thing I want to do is write down an assignment.
Just don't tell them about it since they're late and then when it's due.
No, then they'll be in trouble. I know. 4, 7, 11, 16.
When does this due?
18. When do you want to do?
It's so long.
I was thinking next Wednesday.
A week? Okay.
Yeah.
Okay. Is this our homework?
Yes.
That's what we're going today, Grace.
Joe, you know next Wednesday is fall break, right?
I know.
So like we don't have class.
Yeah, we do.
They changed it this year.
Oh, right. That's right.
Oh, I really thought she was serious. Haley.
No, I'm not too busy.
I am catching a flight that night.
I said we've got a
Well,
midterm.
then you don't really want to grade homework over your lunch.
Probability that Tuesday.
I got a 3-hour flight there and back. So
If we turn in early, then
3 hours. Where
Las
you
Vegas.
I don't like this. It's hot.
We don't have probability next Wednesday, right?
That's not.
We don't have probability next Wednesday?
We do not have probability next Wednesday that we have an exam.
So-
we turn the homework in early.
Yeah, jumping off of what Marcia said.
Yeah.
If we turn it in early, we still have class.
I'm still gonna have class.
Yeah, but class is optional.
Class is always optional. I don't think
I know.
that.
Class is optional.
Anything out here.
Like, class is always optional.
Just think Tuesday night after probability test. And just crying the whole drive home.
Oh, shoot. All right.
Not for 2 hours.
I want.
It's all from the same worksheet.
What's that?
It's all from the same
It's all from the same worksheet, yeah. And that's the one we were working off of last time.
So the increasing annuities is what that is?
And then we're going to be doing decreasing annuities as well
Okay.
today. And perpetuities today. Or increasing perpetuities today.
I forgot the equation for that. Is that the like 1 over DI and 1 over D squared?
Mm-hmm. That's correct. I know. All right, so I do want to derive a couple of the formulas today, and then we'll do some more problems. Does that sound like a plan?
Yep. Oh yeah, we never did that.
What's that? We didn't derive. Yeah, we didn't derive any of the problems or any of
I
the
think we should
formulas.
work on problems first.
No, we're gonna derive first.
Problem 1.
It's not gonna take that long. I promise.
Are we gonna have to do integrals or derivatives?
Not today.
No, thank God. Okay. Then maybe what we said.
Not in here. We're gonna have to do integrals and derivatives and
What about like
probability, but you're not.
what about like logs and stuff? We're gonna do logs.
What do you want today? No, well, not for this. I mean, you can always might have to take a call. We're gonna do a force of interest. You're just
I'm just being
contrarian.
You're not getting it.
Today?
You are? Oh no.
You
said 1 person.
Sorry.
It's okay. What was the date yesterday?
Yesterday?
The
Yeah, yesterday was the 8th.
8th?
All right. So the idea behind the formula for the increasing annuity, remember when you have an increasing annuity, or what we call an increasing annuity, is that the payment difference and the first payment are identical. So when we derive the formula, we start with a payment of 1 and then go up by 1 each time. So when we have that IA formula, and it's going to be the same concept with the DA formula for decreasing annuity, the first payment and the amount of increase for increasing annuity have to be the same. For decreasing annuity, it's the last payment and the amount of decrease each period has to be the same for the formula. Okay. So if your first payment for increasing or your last payment for decreasing is a different amount, that's when we split it into a level part and an increasing part, or a level part and a decreasing part. Okay. But for the formula to work, we need first payment and amount of increase to be the same. So then we just approach this by doing present value. We approach this like we do everything else. We just move them all back to time 0. So what would I need to do? What do I need to multiply the 1 by to move it back to time 0?
1 plus I.
Yeah, so I do a 1 plus I to the negative 1 or a v to the first, right? So I need a 1 v to the first for the 2.
V squared.
Yeah, 2v squared for the third.
Are the constants your like $1 payments?
These are the, yeah, this is starting with a $1 payment increasing by 1 each time. Yep. And then so on up the line, right? The last one will be an n v to the n. We agree?
Yep.
Okay. We could do this by noticing that this is a geometric series, and we could play around with it a little bit that way. But I want to do it a little, I mean, we're going to have to use a geometric series in a little bit. This looks like a derivative of a geometric series, kind of, but I'm not going to, it works better if it's an infinite series anyway. It recognizes a derivative. But instead, I'm going to be a little bit clever, and I'm going to line up some terms by taking this present value and multiplying both sides by something. And I should have moved this down a little bit to save a little bit of room. So let's just do that. So, what was that? That's fancy? All right, so what I'm going to do is I'm going to multiply both sides of this equation by 1 plus I. Or basically divide both sides by v, if you will. I'm going to multiply both sides by 1 plus I. Ooh, hey, that one went off crazy. 1 plus I times PV. When I do that, what does this first one become? If I multiply by 1 plus I? Just 1, right? The second one becomes 2v. So I'm going to line it up right above the 1v. Right? It'll be a 2v to the first, right? When I multiply this one by 1 plus I, or sorry, this one by 1 plus I, we get a 3v squared, right? The next one would be 4v cubed. So on up the line. This one will hit the previous term, so it'll be an n v to the n minus 1. It'll be lined right above an n minus 1 v to the n minus 1. Now, why did I line it up this way? What do you think I'm going to do with these two things? Why do you think I line them up? Either add or subtract, right? In this case, I'm going to subtract. Because notice if I subtract, what do all my coefficients become on these? 1, right? So what would I get on the left-hand side if we subtract? We get PV times I, yeah, because I got a PV and a minus PV, right? So if we subtract this, I just get an I times the PV, right? First term is a 1, right? Second term is just a V. Third term is a V squared. Fourth term is a V cubed, all the way up to a V to the n minus 1. And then notice that this doesn't have anything above it, right? So we're just going to get a minus n v to the n there. By the way, does this look like part of your formula for the increasing annuity formula? Sure does, doesn't it? Okay. So let's look at this piece. How many payments would be, well, look, notice that these are level payments now, right? We can think of this as payment of 1 at time 0, payment of 1 at time 1, payment of 1 at time 2, all the way to payment of 1 at time n minus 1. How many total payments are there? N of them, right? But instead of being at the end of the period, these payments are all at the beginning. Right? So we can think of this as an n payment level annuity due. The present value of that, right? Because we got all the V's in there. So that piece is just your A double dot bracket N. Does that make sense? You see that? So then if we divide both sides by I, our present value then is just this A double dot bracket N minus NV to the N over I. And that's the IA angle N. And technically, I suppose I should put the little I here and here, but hopefully it's understood that you have to have the same I's there anyway. No, it's not understood. So that's where that formula comes from. See, that wasn't that bad.
That one wasn't the worst.
Was that?
That one was not the worst one.
No, it was not the worst one. Like I said, that was not that bad. All right. And then if you want to get the formula for the future value of an increasing annuity, I can multiply both sides here by 1 plus I to the n. And so that formula, if you don't want to remember the formula, you can just know that you need to multiply it by 1 plus I to the n. That would be my suggestion to do anyway. But if you like the formula, when I take, let's look at the different pieces. If I multiply this by 1 plus I to the n, what do you get? You just get n, right? Because the 1 plus I and the v are reciprocals of each other, correct? So you multiply this piece by 1 plus I to the n, you just get n. When I take the present value of the annuity due and multiply by 1 plus I to the n, what do I get here? You get the s, you get the future value, right? So this becomes s double dot n minus n. What are you laughing at, Haley? I can see you smirking.
My roommate just texted us all
Yeah.
to ask where all the spoons went. Apparently, there's only like 2 spoons left.
Oh,
They're not in the sink or the dishwasher.
okay. I can see why you were a lot amused by that. All right, so again, you don't have to memorize the new formula if you remember how to move money around, which is kind of what we're doing, right? But if you want to remember the formula, this is the formula. Questions on that? One of the reasons why I wanted to go through the derivation is because some of the problems that you might encounter on the exam, the actuarial exam, is playing around with the different formulas. So that's one of the reasons why we go through the derivation. Plus, it's good. That's a good mathematical exercise. It is. It doesn't feel that way?
I don't need to know that. I just need to know the equation.
Being able to play with the formulas, you do need to know how to do on some of the problems, though.
Yeah.
Yeah.
I'll figure it out.
Well, that's good. I'm glad. I like the confidence.
Yeah, those are oddly like the easier ones, I think.
The ones where you just play with the
Because
formulas?
if you know the formula and you know algebra, it's not hard.
True. I don't disagree.
It's a lot harder when you struggle with algebra.
All right, let's do decreasing annuity now, because it's similar. All right, so for decreasing annuity, same idea. We just have to turn the payments around. So same concept like we did with the increasing annuity. If we flip things around, we need the very last payment to be the same as the amount of decrease each time. So if we have n payments, I'm going to start with a payment amount of n and end with a payment amount of 1. Assuming that our payments start at 1 and start at n and decrease by 1 each time. So that would be our time value diagram, which I rarely ever use, but some people think it helps. So I try to draw it. I try to remember to draw it. This is where I'm an algebraist. Pictures don't help me much.
That's fine. We forgive you.
Yeah. All right, so how would we express the present value of this payment stream in this case? How would I write it if we followed a similar thing like we did to start the last part?
Are we leaving space again?
Yes, I was. Actually, I think in this case you could go the other way around, but it's fine. We'll leave space. So I'd have NV. Okay. Okay. Etc. And 2v to the n minus 1 and v to the n. We agree with that? Yeah? So what do you think we should do this time? What did we do last time? Multiply by a 1 plus I, right? And the reason, again, that we did that was so that we could shift some things and do a subtraction, right? So in this case, if we multiply by 1 plus I, I'll do it on top just because we did it that way last time. What do we get if we multiply both sides by 1 plus I? Okay.
N minus 2 times b squared.
Okay. That's fine.
We have to do that.
Okay. That's fine. What's going to be what will be the exponent if you do the 2? N minus 2. And then b to the n minus 1. Bless you.
Thank you.
All right. So now again, what do you think we're going to do with these? Subtract them again? Okay. So we subtract again. We get an I times PV on the left, just like we did last time. Notice there's nothing below this first one, so we just get an N, don't we? Now when we subtract down, what signs are we going to get? Minus each time, right? Because you're going to have N minus 1 minus N, which will give you a negative 1. Then minus 2 minus N minus 1, which will give you a negative 1, and so on down the line, right? So we're going to get a minus V squared minus V cubed minus 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 V to the N minus 1 and a minus V to the N, the very last one. Does that make sense? It's very similar to what we just had above, wasn't it? Now let's just look at this piece. What does that look like? Say it again. It looks like an annuity immediate, doesn't it? It's like we're subtracting it off, doesn't it? If you factor in a minus 1, you got a V plus a V squared plus a V cubed all the way up to a V to the N, right? So I'm subtracting off a present value of an annuity immediate, right? So that part there looks like an A angle N. So if we divide both sides by I, you get N minus A angle N over I. And this is your present value of a decreasing annuity. This is why I said that if you, however you best memorize formulas and terminology, I would do that. So flashcards or keeping it all on the same sheet, have a running sheet of things. I emphasize sheet because sometimes I mispronounce words. Problems? You have problems?
I do.
What?
Our biggest one.
What's that? Is that big one right there? All right. This one, there's not a fancy formula for doing your decreasing and future value of decreasing annuity. So literally, the only thing you have to remember for future value for decreasing annuity is to multiply by 1 plus I to the n. There's nothing nice that, I suppose you could make it a minus S angle N here, but you still have 1 plus I to the n times n, so there's nobody writes down an actual formula for that one. All right, you can do the same things for increasing perpetuities. I'm just going to write down the formula since you all are clearly so interested in the derivations. I can tell.
They were very cool.
I thought they were cool.
I know.
By the way, does it make sense to do future value of a perpetuity?
No.
No. All right. Doesn't make any sense to do future value of perpetuity. So present value of increasing perpetuity for payments of 1 and increasing by 1. 1 over ID, or this is 1 over I plus 1 over I squared. Those are the same thing. And you can do increasing, that's an increasing perpetuity immediate. This would be increasing perpetuity due is 1 over D squared. You know, and I should probably have mentioned, for the other formulas, you can change them from immediates to dues by doing the same thing you do with your annuity due and annuity. For your annuity due formulas for just level annuities, and that's just change your I to a D in the denominator. It's the same formula otherwise. That's okay? All right, you want to work on problems, apparently? Yeah? Yeah, that was what my plan was. Let's see. Is that a good plan? Let's see. Did I mark anyone with a decreasing annuity?
Are we doing H to I?
Say it again. Yeah, it was the same same one. Why don't I have ones that are decreasing? Work on number 9 on that one. That's a decreasing one. What's wrong?
I said a nap sounds like a good
A nap sounds like a great idea. I get on board with a nap.
I think it should be class.
Yeah, I know. I know what you think. You think we should. You know you're paid for class, right?
Thank you.
I always amuse me when students want to cancel or get out early. They get paid for this.
Yeah.
Actually, I'm paying to get my degree. I mean, I get my degree whether or not, like, we just have to have a certain number of classes.
But your degree's not going to be worth much if you don't learn the material.
You're not going to get your degree if you don't learn the material.
We'll see, like,
There are some classes
Nice.
that it's honestly just more effective to learn the book on your own time and only go to class when you have a test.
Stephen Wall.
Exhibit A.
Why didn't come in and say it again? Well, then at least me and Julia to do all the work.
Yes. I've got opinions.
No, because you couldn't. Dr. Olson couldn't even get
I said I have
it.
opinions. On what Cindy's talking about.
He's literally talking about it right now.
I wasn't paying attention though, and then at that point it was too late. I just got
That's
put out.
your excuse for everything.
What?
Not paying attention.
That's
I
because
didn't
most
get
of the time I'm not paying attention.
How do you say that?
Francois.
Frenchie Francis.
Frenchie Francis? Like Frenchie fish distribution.
Yeah, that's what I was
French
That's what I
fry.
was thinking.
Was it?
French fry.
French Frank?
That's funnier.
Frenchie
You
Frank.
could have French franks with French fries.
Is this-
What? Did I miss something?
Hot dogs are called franks. You can have French franks.
With French
fries.
Wait, hot dogs in France are called franks? Is that what you're saying? I can't
No.
process what you're saying.
Hot dogs, another word for hot dogs is franks. Like if you look at something, it says like 10 beef franks.
When?
Always.
I hate hot dogs. That's why.
But it's not chicken.
Okay.
Chicken, you know.
I'm weird
What do
about
you like?
chicken from restaurants. Okay.
You're weird about all food from restaurants.
Okay, well, I'm a little wary about some foods, but chicken I just never really like to order at a restaurant because you never know how it's going to taste.
Not even chicken nuggets.
I don't like chicken nuggets.
Like Chick-fil-A.
My thing is, I don't like any type of like frozen chicken that you could bake. I don't like. It has to be like fresh.
So what do you do when you go to a restaurant and like they got all these new foods and the only thing you know on the menu is chicken tenders? Chicken tenders.
The only thing I do, I order something else.
You don't order the chicken tenders?
I eat burgers at restaurants and
Joe is so done with that.
You eat restaurant fish before you eat
I
chicken?
love, it has to be a good restaurant. I'm not just gonna order from like Culver's, order their
That's
fish
real
fillet.
suspect.
Dude, filet of
That's
fish
real
McDonald's.
suspect.
Yeah, I would never
I
order
think
that.
it's not even real.
I
I
don't know
love
Gracie's
fish.
first.
What?
Yeah, let's just, Grace,
You're all talking, Grace is working.
Grace can focus. I got distracted with the burger.
The Frenchie Frank?
Yeah, and then you distracted me because I didn't know what you were saying and I didn't get it.
Dr. Joe thought it was funny.
I thought it was funny.
This is too much.
But it's not too hard to distract me either. So.
I pay attention to a goldfish, so.
Who's payment at the end of the year?
Stop. Oh wait, I have to look at stuff.
What's that?
I still want to put my list of formulas.
Oh.
My math notebook. Still in my.
I think I had this set up here, right?
Oh, yes.
I got there, it just has error 1 already displayed. It's like, I didn't even do anything.
Well, your first error was turning on the calculator.
Calculator is feeling passive aggressive today. They're not going to
It has issues. Yes.
Oh, you wrote cursive.
I was right.
I think it's just cursing.
Not yet.
That comes later.
That comes later. It does.
I thought that's me. Right, I think it's That's what you said one time.
We didn't get why you wrote in cursive.
Oh, was that it again?
I like her.
Don't the X's cancel out? I got a
You
small
can't read
print.
it, but.
Print you like it.
Here, annual payments bags. You haven't incorporated the 50 in,
This one's.
right? Because you don't know that it starts at 50 and then ends at, yeah. So you have to incorporate the 50 in there somehow. But, yeah.
I don't know if I have this set up there. So I should just couldn't use this back because I'll put the same present value.
Well, this is the same issue. So I don't know that so for decreasing annuity, the amount of decrease in the last payment have to be the same, right? So it says that you're decreasing what was paid in the previous year by an amount equal to X, right? But I don't know what the last payment is at the end. So we've got to incorporate this 50 and this X in there. So it's not quite set up on the right hand side.
Would be 55. Right, it's reducing that.
Well, I know that the amount of decrease is X each time, yes. Right. But I don't know what I'm cutting off. So if I think about the time value diagram, what was this? Year 1 through 10? Is that what it said?
Yeah.
Yeah. Okay.
Would you just do 50 minus 10x times the annuity and add the increase in the
Oops. Right? We agree? That's what that looks like for the payments each time? Yeah. So probably the easiest way, at least what, I'm not sure it's the easiest way. The way I would think about it would be I would have a level annuity of 50 each time, right? And then I've got this other annuity that decreases by X each time and starts at X. So I would have two different annuities. That's how I would think of it. Wait a minute.
I'm still trying to understand the setup of this one.
Wait. Not a decrease. It says it decreases by each one. I'm sorry. Let's try this again. I would think of it as a level annuity and an increasing annuity, even though it says decreasing here. And then do the difference of the two.
Why would we learn a decrease?
Say that again?
Why would we just learn a decrease?
Because some of them have decreasing in it. This one I think you can think of as an increasing one. It's harder to get. I think it's harder to get at this one with a decreasing one because I don't know what the last payment is. Because remember, the amount of decrease each time has to also be that last payment. But since I don't know what X is, it's a little harder to get at it. So I would do it as a difference of a level and an increasing in this case. You don't like that here?
I just, like, are we subtracting the present values?
Yes.
Oh, okay.
Yeah,
I was
yeah,
gonna
yeah.
say, if you're adding them. then-
No. I would subtract the present values.
You lost me there.
No. You want to subtract the present values in this case. That's how I would handle it. What else is in this section? Oh, I know what else is in this. Bless you.
Thank you.
Oh, I forgot to mention that I also put a couple more videos up with an increasing annuity example, a decreasing annuity example, and an increasing perpetuity. And I also did it where I typed up the presentation rather than write it and read my handwriting.
Is it on your channel?
Yeah, it's on my channel. Yeah, that one's on the class channel as opposed to the theory of interest, the theory interest channel. I thought it might be helpful. I don't think any guarantees. I did not draw any time value diagrams, though.
I think I got it.
You think you got it now?
Yeah. I think I got this set up.
Okay, let's see what you got.
So you deal with this, right? You break it up.
Yep, except that you've got to be a little bit careful on this last one because there's only 9 payments. So when you do this one, it only gets you back to time 1.
Right.
So you have to still move it back 1 more period. Because when you do the present value of the annuity immediate formula,
Right.
it just goes 1 period before the first payment.
Right.
1 period before that X is time 1. And you're trying to equate it times 0. So I'm going to take that and multiply it by a feet and go back to the, yeah. But other than that,
Okay.
other than that, you're good.
Makes sense. Thank you.
Yep. What were you supposed to do? Yeah, when is it? Although the weather in Colorado is supposed to be crazy the next 2 days. It's supposed to be 80 in Denver today and 20 tomorrow.
What? How does that even happen?
Yeah, big old storms going through. It's ridiculous.
Hey, did Julia ask you about the thing? Okay.
Yeah.
I was supposed to go with her and she.
Oh, yeah. I'll pay for it. No faculty are going, so you'll be on your own.
Don't get arrested.
Yeah, I don't care if I get arrested or not. Makes 0 difference to me to get arrested.
Okay, do get arrested.
Just don't call me. Anytime I take students to conferences, one of the things I say is don't call me to tell you how you get arrested.
I don't know. Is that a name? I don't know what that is.
Pardon me. Sorry. That was a big sigh, or whatever that was. Honestly, it looked like you were getting ready to blow up a balloon.
Trying to stay away.
I'm sorry. I'm like very interesting today. My bad.
No, it's just 3 practices in a row.
I'm running in the dark, isn't it?
Yeah, it's the last 3 practices.
To run in the dark.
We ran through therapy yesterday.
I have no. I just don't have it.
Yeah, I can't find mine. I have levels.
Do you have it on your computer?
I do, but I was going to leave the screen up.
What were you telling me last about the moving the other one back?
So that increasing annuity that we have that starts at X and increases by X each time, the first payment is at time 2. If I use the present value of an increasing annuity formula, it only moves it back 1 period prior to the first payment. So that IA angle 9 would be the value at time 1. I need to move it back 1 more period. I need to take present values. So I need to multiply by V.
So it has to be 9?
Yeah.
That's the same divide by.
Not quite. Yeah, well, there's only 9 payments of X. So it's IA angle 9.
Oh, I messed that up.
Interest rate.
0.07072.
Oh, so it's 1.072%.
It's kind of long. Watch it right.
No, it's because it's making a present value on these 7.
Unanswered.
Well, that's good.
That's the right one too. I think it's right.
What'd you get? What'd you get, Jake? I got D. What's it? What is D? What number is it? Sorry.
3.5.
Okay.
I got 3.8.
So I got 3.5 B. 9. So yeah, what would be? I know. I get it in begin mode, by the way.
Whoa, Dr. Joe,
What did
what
I
did
do?
I do wrong?
I got a 9.2.
That's
I know it's not right.
This is not correct here. If you can remember, this is present value of annuity two. Yeah, that's what you get.
darn it.
Dr.
So what
Joe,
did you wrong?
look at mine.
Why am I done?
Oh,
You, I bet, did not take your 29.5364 and move it back one period. You need a B in front of that.
Why?
Because
It's not.
because that present value of your annuity, increasing annuity, only moves those payments to time one. So you need to move it back one more spot. So you need a V with your 29.5364.
It's didn't hurt that A angle 10 is 7, effectively.
Yes, yeah, A angle 7, A angle 10 being 7 helps. That's why they had that goofy interest rate.
Yeah.
What's that?
I said, why did I have to mess up?
Dr. Joe, I don't think that little issue is gonna solve my, rather large problem.
Where to go?
Let me see.
I think
Or I just typed something in my calculator wrong.
there you go.
I definitely just typed something wrong.
That was it. That was just that one little number. So again, the point, at least the big point of this one, besides getting your two different annuities set up here, besides getting these two annuities set up, is this piece right here. Remember when you use, like I've mentioned a few times, when you use this formula, it gives you the value, we call it present value, but what it really does is it gives you the value of the payment stream at one period previous to when the payment stream starts. So in this case, the way we've written the annuities, this X started at time 2, so that when we use the present value formula, it just moved it to time 1. So I need to multiply it by an extra V to get it to time 0. The other formulas, since 10x and 50 both start at time 1, the formulas take you back to time 0 to start with. Does that make sense? So that, I mean, there's two big parts of this. There's two big parts of this particular problem in my mind. The first big part is splitting it into two annuities. That's problem 1. In particular, it said it was a decreasing annuity, but yet we split it into a level and an increasing one. Right? And then making sure for the increasing one, we got it back to the right time. And then after that, it's a matter of getting everything in your calculator. Just like Nick mentioned, it doesn't hurt that the A angle 10 essentially turns out to be 7. It helps a lot as far as computations go. Any questions on this one? What I'm hearing is we probably want to do some more problems on Friday. Yeah? Okay. We'll do more problems on Friday. All right. Okay. Yeah?
I got an answer.
Yeah. You got an answer?
Yeah.
Cool. Here's the good news. Remember that if you're taking the exam FM, you need to be able to do these problems in less than 6 minutes.
Isn't it less than that? Aren't there 35?
That's what I said, less than 6 minutes, yeah.
How long needs to go?
The big issue is that You can set up enough practice where you can read the problem and know immediately what you need to do.
Be about
So that if you-
5 minutes and 8 seconds.
Yeah, something like
You also gotta be able to do past the fun names without.
Yeah, and what else? They're talking about Frankie French or Frankie Frank or whatever we said. All right. Good news is I don't think chapter 9 will take very long because there's just one formula there. It's just having to be integrals in those spots. Good.
I'll bring my drop one by later.
The good news about the integral problems though is typically they make it to where things are nice. So for example, one of the integrals is up in your exponent for e, but the integral typically involves natural log. So the b and the natural log will be the same.
So I'm hearing that there's not a lot of integration by parts.
There can be, but typically
Maybe I won't bring my drop one back.
there is no trig substitution.
Well, that's good.
No partial fraction.
That's good too.
Integration by parts is the worst.
Why is it the worst?
I think out of all of them, I'd rather do extension, I'd rather do integration by parts, and I'd rather do integration. What was the last one we said?
Partial fractions? That one?
So you'd rather do trig substitutions?
Those are like easy though.